Okay, so surds is a fancy word that basically means that I have a root in the question. For example, that's a surd. It has a square root in it. Okay? So that's not very complicated. It's just a fancy word for something you've already met before. Now, there's something that we know about square roots. Square roots are the opposite of what?
Squaring.
Squaring. So if I have a number and I square it and then I square root it, I get the same number back again. So if I had the square root of 5 squared, what would the answer have to be?
5.
5. Because I haven't done anything, have I? Because I've squared square rooted. Well, if I squared and I got 25, square root, I get back to 5. Shh. Charlie, you need to stay with me. Focus. Focus. Put that down.
8 squared.
Okay, so if I square and square root, I always get back to the same number. What if I made it a little bit trickier and I put it in brackets and I put 2 things in there? Say I had 2 root 3.
2 root 3.
And I'm going to square that. Okay? Now this squared will affect everything in the brackets. So I have the number 2 and I square it. What's 2 squared?
4.
4. I have root 3 and I square it. What's root 3 squared?
3 squared.
3. And 4 times 3?
12.
12. So whenever I'm squaring, quiet, I need to know that the squaring cancels out the surd.
Where did you get this times?
Where did the times come? What's between this 2 and the root 3?
A divide.
An invisible times, okay? So remember, we don't need to write it in. We understand if there's no symbol there, it will be a times. If it was a plus or a minus or a divide, we'd have to write it in. Okay, so that's really important. Shh. What we're going to look at today is simplifying surds. Okay? Some surds are very easily simplified. For example, what's this one? 3. Okay? So, if it is one of our square numbers, remember we practiced looking at all these common square numbers. If it's one of those, you can just square root it. Matthew, focus. If I have, for example, this one, the square root of 8, it's not a nice number. And I don't want to go for the calculator because we like to have exact answers, don't we, Abby? Yes, we do. We don't want to have decimals. They stop you from getting full marks. Now, the 8 can't be simplified. But I know that one of those square numbers divides nicely into 8. What square number divides nicely into 8?
64.
No, into 8. Not 8 goes into.
4.
4. So 4 divides nicely into 8. So 8 is the same as 4 times 2. Do we agree?
Yeah.
Yeah?
Okay.
So 8 is the same as 4 times 2.
Okay.
Okay, that's like primary school maths. We're good with that?
Yeah.
Okay. Quiet. So these are the same. We're happy with this. Now this means the square root of 4 and the square root of 2. I know the answer to the square root of 4. What's the square root of 4? 2. 2. So this bit here, that becomes the number 2. What about the square root of 2? Can we do that?
1. No, 0.
It's some yucky number. It's 1.41 blah blah. It's a yucky number. We don't need to recite it out.
1.4.
So it's going to stay as root 2. Note that the times disappeared. Why did it disappear? Because we know if there's no operation, it's an invisible times. So this surd is now fully simplified because the number 2 has no perfect squares that go into except 1. And there's no point rewriting it as 1 times 2, is it? Okay, because it's still going to have a root 2 there. Alright, let's look at another one. How would we simplify, let's say, the square root of
64.
200?
And 71.
square root of 200. Now, give me some numbers that multiply to give 200.
100.
So 10 times 20, 2 times 100, 4 times 50,
1 times 200.
1 times 200, 8 times... Okay, there was a lot of answers.
2 times 12.5. 1 times 200. 200 times what?
Quiet.
Hey, what?
Quiet. There are lots and lots of pairs, lots and lots of factors that multiply to give 200. The one we're interested in for simplifying is one that involves one of our perfect squares. So only one answer involved a perfect square, and that was Emma's answer. What was your answer, Emma?
0.
2 times 100. Now we like that answer for simplifying because 100 is one of those special numbers
It's 10.
that we can square root to. It was 10. Well done, Bryce. So it would be 100 times 2. Is everyone happy with that step?
Yeah.
Okay. Now Bryce, paying attention. So Bryce just told me that the square root of 100 is 10. Now the square root of 2, we can't do that one, can we? So, okay. And do I need to write the times in anymore? I don't need the times anymore. I know it's still there. So that's 10 times root 2. That is a fully simplified surd. Okay? We following?
I get it.
We understand?
I'm ready to get it.
Alright. Let's look at one more. Let's say I have
2.2195.
square root of 75.
What about minus?
Quiet. Quiet. Square root of 75.
3 and 5.
Careful. 75 is what times what? Remember, we're looking, Bella, we're looking for a perfect square. What factors have a perfect square?
3 times
25 and 3.
7.
Okay? Now I can't square root 3. It's not a nice answer. We're going to leave that as a root 3. I can square root 25. What's the square root of 25? 5.
5. 7.
Now, I'm always going to put the number in front of the surd. Okay, so even though here it says 3 times 5, it's much clearer to read. It's going to look like a 35 otherwise. Much clearer to have the whole number in front of the surd. So 5 root 3 is 75, fully simplified. Alright, we're going to leave it there. I'm going to get you to try a few of your own before I go into the next idea.